We're going to talk about elasticity today. Now, just to get a sense of where we're going, first we'll talk about the price elasticity of demand, then we'll talk about the price elasticity of supply, and finally the effects of elasticity on changes that happen in markets. But just to get some motivation of why elasticity is important, first, consider a decrease in the supply of gasoline, as we might graph here. So here we have our standard downward sloping demand curve, our upward sloping supply curve, that's the first one there. But then supply decreases or shifts to the left. Right? So we have something like this. Now, as we can see here in the graph, it's very clear that our equilibrium shifts upward and to the left, showing that we have a significant decrease in the quantity of gasoline and a small increase in the price of gasoline. Now a question for you. Do you believe me? That is, do you believe the story that I just told you? You really shouldn't. The directions, it's true, are all right. Yes, if the supply of gasoline contracts, prices are going to go up and the quantity purchased is going to fall. However, the magnitudes are all wrong. Is it really true that people are going to stop buying gasoline so quickly? They're going to fall, as the graph showed, almost by half. Is that really true? Are we going to lose that much gasoline being purchased? Well, probably not. I would guess that the quantity purchased is going to fall very, very little, not very much. And that's exactly what elasticity is supposed to get at. So, price elasticity of demand starting out. Price elasticity just captures how sensitive buyers are to prices. Or for the price elasticity of supply, it would be how sensitive sellers are to prices. I would note here there are other elasticities that I'm not particularly worried about in this video. One of those is income elasticity, so it captures how sensitive we are to changes in income. So as income goes up, do we buy a lot more of the good, or just a little bit more, perhaps less of a particular good? There's also something we call cross-price elasticity. That captures the sensitivity of demand in one market to changes in prices in another. So this would be the case where we know that our demand for, say, peanut butter depends on the price of jelly. If the price of jelly goes up, then our demand for peanut butter will tend to contract. So the cross-price elasticity is to capture that. So the price elasticity of demand. First, it's defined as being a measure of how much the quantity demanded of a good responds to a change in the price of a good. Elasticity really answers the question. If prices were to increase by 1%, by what percentage does the quantity demanded decrease, everything else equal? Or we could reverse that and say, if prices decrease by 1%, by what percentage does the quantity demanded increase, all else equal? So it's all to capture that relationship between prices and quantities demanded, and quantitatively what that relationship is like. Our formula for the price elasticity of demand, which we denote by eta d. Eta is a Greek letter. It looks kind of like an N with a tail on it. Right? The way we calculate it is just take the percentage change in quantity demanded. Here the triangle is a large delta indicating change. So percentage change in quantity demanded, divide that by the percentage change in price. For example, suppose that when the price of a particular good rises by 10%, the quantity of t-shirts purchased falls by 2%. So here we're looking at the price elasticity of the demand for t-shirts. In that case, our elasticity would be measured as 2%, that would be the change in quantity, divided by 10%, the change in price, both in percentage terms. So 2% divided by 10% is just 0.2. Now one thing we could note here is that technically that should be a negative number. After all, the quantity of t-shirts purchased fell, so the change in demand was a negative 2%. But here we just drop the negative sign, understanding that demand always slopes downward, so we'd always get a negative number. So what this 0.2 tells us is that if the price of t-shirts were to go up by 1%, the quantity of t-shirts demanded would fall by 0.2%. Now when a demand is a straight line, we can use a little bit different elasticity calculation. We take any 2 points on that demand curve, and here's how we can calculate the price elasticity of demand. We look at the difference in quantity between those 2 points, it's Q1 minus Q2, divide that by quantity. This would give us a percentage change in quantity. Then we divide that by the change in price between those 2 points and divide that by price. Now, a few notes here. The Q1 and P1 should come from the same point on the demand curve. The Q2 and P2 should come from the same point on the demand curve. So we have two different points, one providing Q1 and P1, the other one providing Q2 and P2. Now the generic Q and P in our formula here, those can be from any point along the demand curve where we're interested in the price elasticity of demand. Just as an example, suppose that demand is linear and includes these 2 points. At $10, 130 t-shirts are purchased. At $11, 125 t-shirts would be purchased. So increase the price by $1, we buy 5 fewer t-shirts. The elasticity of demand at $10, to get that, we need, remember, 2 points, providing our quantity 1, price 1, quantity 2, price 2, and we also need the quantity and price at the point of interest. So to plug all that in, our 2 quantities would be 130 and 125. Our 2 prices are 10 and 11. The quantity we're interested in, we're looking at where price is $10. Well, at $10, the quantity is 130. So we plug in 130 for our Q. The price we're interested in, we know is $10. So we plug in 10 for our generic P. Then we do the math. We find out we get 3.8% divided by 10%, or 0.38. Now, one point that I want to make is that elasticity is typically not constant along a demand curve. In fact, it will change at different points. So here we have the elasticity at $10. What about at $11? What's that like? Well, here we use exactly the same formula. It's the same 130 minus 125, but now instead of dividing that by 130, we're dividing by 125. Take the same 10 and 11, subtract them to get the difference, but now rather than dividing that by 10, we divide by 11. So our point of interest has changed from being a quantity of 130, price of 10, to being quantity of 125, price of 11. And that change is enough for us to get a different value for elasticity. Here we have 4% divided by 9%, or 0.44, being our new elasticity. Right, so just reminding you about these points for the formula for the linear demand curve. Remember that Q1, P1 pair and the Q2, P2 pair can be from any 2 points on the curve. Pick any 2, it doesn't actually matter. Right. This actually makes it very easy to calculate elasticity at multiple points, as in this formula we only have to change the quantity and the price at the point we're interested in. We don't have to change Q1, Q2, P1, or P2 once we've picked any 2 points along the demand curve. So this is very, very nice if we need to calculate elasticities at a number of different points along a demand curve. At the same time, we know demand isn't always linear. Let's say it's not always a straight line. Sometimes it might have a curve to it. Sometimes it might be curved one way or the other. Sometimes it seems to be, say, a straight line for a while, but then it gets some kind of curve to it or has a kink in it, where suddenly the slope changes. In that case, we need to use a different measure of elasticity. Here we use what we call the midpoint method for calculating elasticity. What this does, it actually calculates elasticity across a range of a demand curve. So here, the 2 points that you pick to get your Q1, Q2, and P1, P2 actually matter, because the elasticity you get will be measuring roughly around the midpoint between those 2 points. So here we have the formula sitting in front of you. So we look at the difference in those quantities, Q1 minus Q2, then we divide that by the average quantity of the 2 points, or Q1 plus Q2, divide that by 2. And we do the same thing with prices. Take the difference, divide by the average price for the 2 points that you chose. Right, so in effect, it's just a reminder that it does calculate elasticity about halfway between the 2 points. This is a good thing to know, as it is potentially useful, as we normally don't have any reason to believe that demand is linear for any particular market. But in terms of if you're taking, say, the course from me for credit, I really expect you to know and apply the linear form, as it is somewhat simpler and certainly easier to use on a large number of points.